All right, it's 9 o'clock on the dot, so let's get started. So first of all, I want to say thank you all for attending this talk. I know there's a lot of other things that you could be potentially listening to right now, and I'm going to hopefully live up to the commitment that you guys made to be here and give you guys a lot of practical advice on how to take advantage, I think, a lot of the open source tools that you may have been hearing about throughout the conference. If you went to the security workshop, if you went to Zach Washman's talk yesterday, where they were talking a little bit about osquery. I'm hoping that this talk can be a little bit more practical in terms of how can you actually utilize these tools effectively within your organization. So the title of the talk is How Software Engineers Ruin Macs and Can Ruin You. And I think that the purpose of this sort of like inflammatory title here wasn't just to get you all in the room and fight me. It was really just to kind of get this sort of theme out there where, and this is going to be a big part of my presentation today, where we're talking a little bit about how Mac security in general is a little bit more than just understanding the gaps in the operating system or understanding, how intrusions happen. It's about the people that are actually using the devices, how they use them day to day, and specifically with software engineers. My hope is that you walk away today with sort of this understanding that because of their day-to-day jobs and the requirements of them, they actually have to undermine the underlying security model of Mac OS. And you need a really good detection strategy for that. So this is a sponsored talk. And the reason I'm giving you that disclaimer is I will be shilling quite readily about the products and services that my company offers. But I'm also going to be talking about a lot of open source stuff as well that you guys can take advantage of, even if you don't want to pay us any money. But I will be talking about our product, giving a full demo of that. So today's goals is I'm going to try to talk a little bit about why traditional malware and signature-based approaches are less effective security monitoring strategies on Mac OS. These are tried and true monitoring strategies on Windows and other platforms. And I'm going to talk a little bit about why those strategies are a little less productive on an operating system like Mac OS and Macs in general because of the population of users that typically actually take advantage of them. I'm going to try to work with you guys, and this is actually really good that this is a much smaller room because we can have like a really good Q&A where we can kind of develop practical detection strategies for some of the security goals that you have within your organization. And then just kind of walk through the chain of events that can happen that could lead to a pretty bad compromise. And we're going to talk about our products and a bunch of open source stuff. Some of it you've already heard, and maybe we'll have a little bit more of a practical spin on it. My co-founders, Mike Arpaia and Zach Wasserman, are also in the room. So at the end, I'll just ask them to come up, and we can do like a little like osquery Kolide panel as well. Mike is actually the creator of osquery at Facebook, and Zach was the original developer that he sort of conscripted into actually building the first version of it. And so you have like basically the top level like osquery experience in the room. So we'll definitely take a chunk at the end of the talk to kind of utilize their expertise if you guys have questions from all the various like things that you've heard perhaps throughout the conference. And if you haven't heard anything, we'll do a quick reintroduction to osquery so you guys are all at a good baseline. So who am I? I'm the co-founder and CEO of Kolide, but my career's been pretty varied in the 12 years that I've been, working since college. First and foremost, I've been a cybersecurity intelligence analyst. I love just kind of dealing with like really advanced threat actors, like nation state actors. That's where I kind of got my start working for General Electric, dealing with a lot of basic like exfiltration of really like important, Department of Defense type of stuff. I eventually found my way into Mandiant, and they're basically one of the top consulting firms for those types of really heavy-hitting compromises. We used to be called like the $1 million company because if you had to call us, you were probably spending at least $1 million just on the first few visits just for us to help you with a major breach, and we responded to usually most of the breaches that mattered. Mandiant eventually got bought by a security company called FireEye, and I was the chief security strategist there. And I kind of utilized a lot of my software engineering background to build a lot of products. FireEye is a really interesting company because they deal with a lot of advanced threat actors and really like these really sophisticated types of attacks that a lot of large companies with really important data really have to kind of focus and worry about. But in my career, I always found joy kind of like I would say like deconstructing the walls that a lot of the experts in this industry tend to put up, and a lot of the mysticism that exists. A lot of times, like through the use of vocabulary or like kind of like really intense, you know, tools that require like a lot of command line knowledge, you can really kind of potentially block a lot of people out from really understanding what are, at the end of the day, I think really simplistic concepts. And so it's sort of at my mission at Kolide, and one of the reasons that I founded the company with Mike and Zach is, could we break down a lot of those barriers and make some of this stuff more accessible to folks who don't have a 30-person, you know, IT security team or, you know, security incident response team to deal with this type of stuff. You know, they have a 2 to 3 person team at most. Sometimes they're working alone, and some of the security use cases that they have are just as valid as some of these larger companies. So how can we create tools and products that can not only help them find the stuff, but actually distill it down in something that's actionable that they can go and talk to their CEO or their CTO and actually have a productive conversation about. I actually have an IT admin support background. I worked for the University of Connecticut for a while, doing the student support there. And that was like a really awesome experience really early on in my career. A lot of empathy around the types of real problems that you see in that type of environment, whether it's faculty or students or, you know, the graduate student that just like is crying because he lost his like final dissertation and he needs someone like to just kind of do a backup and figure out how to like recover that data. And I'm also a software engineer. So a lot of the stuff that we're gonna be talking about today is stuff that I'm empathetic to because, you know, I've actually lived through it. And a lot of the things that we detect in our product are things that I've seen my fellow peers do, or that I've done, or we've seen in an actual incident response that we've responded to with a customer. So who's Kolide? You know, what's our company all about? So we're a security-focused infrastructure analytics company. And so what does that mean? It means that we want to pull interesting facts about the devices that are in your organization, and we want to make something meaningful from that sort of random set of data that we're pulling in. Instead of just kind of pulling in these individual points, how can we kind of correlate all this information together to tell you a story about something that happened or about a risk that's sort of, you know, potentially propagating in your environment? This is really hard to do, and it's not something where you can like develop an algorithm once and then just apply it to all the data. You have to think of like the use cases first and really kind of devote a lot of time and engineering to making just one of them work really consistently. And so our mission is to kind of do that for all the important use cases and the risks that technical organizations really have to face using tools like osquery to kind of pull that data in. So we're getting there over time, and we feel like our mission will be satisfied when you guys sort of feel as though, okay, we could kind of roll this out ourselves, but Kolide is just like basically they have a full-time team that just sleeps, eats, and dreams, you know, analytics on top of this data. And we try to answer all the infrastructure questions, but to me the most important part of that is the questions you didn't think to ask. So everybody if anybody who went to the osquery talk, they saw osquery, and they're like, great, like I have access to all this information. I can think of maybe 2 or 3 things I want to know, but what about the 40 other things that you're not thinking of that could be really useful to your organization? That's what we're trying to solve at Kolide. So let's jump right into the talk. So when we started Kolide, we knew that we wanted to target the Mac first. It's a platform that we all use. We're software engineers by trade, and we knew that there's a big gap in the security market where a lot of folks are really kind of focused on the Windows platform and, you know, large organizations that have a lot of like underlying compliance requirements. But could we build something that kind of transcends that and focuses on an underserved part of the market? You know, folks that are coming from technical organizations that have a pretty sizable user base that's on the Mac. And when we kind of approached that problem, we had to think through, what does it mean to build a security product on the Mac compared to some of the other platforms that are out there? So building a security product on the Mac is different. And, you know, on most security products, they focus on attacks by these sort of spooky advanced threat actors that are coming from all these, you know, scary nation states like China and Russia. And they're coming up with like 0-day malware that they just kind of like figure out how to get through osmosis on your device, and it just activates, and then all of your stuff is just flying off of there. And like, this is like the scary fear, uncertainty, and doubt that a lot of these security companies sell you. And if you actually look at all the statistics, I'll have a references slide at the end of this to kind of talk through it. I recommend Verizon has a great yearly report that they put out for their DFIR, and they talk about all the different breakdowns of these various breaches. And the reality is that the majority of these attacks happen on either the Windows platform, if they're targeting a workstation, or they're happening on a Linux server. And the Mac just sort of falls into this weird camp where it's a little bit too hard to break into, where they don't want to rewrite all their tools to actually focus on the Mac. And Linux is just the low-hanging fruit on the server end. So those two investments from an attacker standpoint are way better. So basically, Macs aren't targeted as frequently as the OS itself just isn't low-hanging fruit. So from our perspective, if we had taken all the intelligence that I had sort of come up with throughout my entire career and just try to apply it to the Mac, it would result in like zero alerts or like really kind of low quality stuff. Like, of course, there's always like, the crypto locker stuff and a lot of the ransomware that's out there that you can write alerts for. But the reality is that most organizations, they already have tools today to kind of detect that stuff, like traditional antivirus, or that stuff is typically, caught through some sort of signature-based approach. What can we do that's better than that will actually provide actionable data for the organizations that are our customers? So we decided to take a user-driven approach. So technical organizations of all sizes with a lot of Macs, they kind of have this one thing in common when they're compromised frequently, that they have these like data breaches. And by data breaches, I mean like loss of customer data, loss of like intellectual property, loss of access to really important, production servers. And the problems that if you actually dig into a lot of these compromises that you're seeing in the news, like, the most recent one I can think of is like with Uber last year, where they had that massive data breach where they kind of paid the guy hush money, 100K, to like say, oh, we didn't do it. Like it was just like a bug bounty thing. The problem is that most of these things don't come down to the operating system. They come down to the behaviors that the user is performing on the operating system that put the company at risk. So a lot of it is not adhering to well-documented security practices, inadvertently exposing like really important credentials, or potentially intellectual property to external parties. And what we're going to talk about in this talk is like how that can just happen like that, and you just don't even realize that it's happening through just a series of these random events that sort of happen, and suddenly you don't even realize it, but you've created a massive hole within your organization. So this isn't really a Mac problem if you really think about it. This isn't any platform problem, but disproportionately, the types of people that have this data that have access to this data are engineers and developers, and those people love Macs. And I mean, I'm kind of preaching to the choir here, hopefully. I think most people here are Mac fans if they're MacAdmins. But the creative tools, they're first class or they're exclusive. The hardware is just straight up superior. Software engineers get a real Unix environment. And macOS is just intuitive, secure, and you don't just, as a developer, you don't have to worry about as much annoying stuff. And so that's why you're seeing just a huge uptick in Macs, for the last decade. So we know that if we target this platform, we are going to get the most bang for our buck in terms of finding these types of data breach risks. So that's why Macs are really interesting to us at Kolide. And for folks that sort of meet this criteria, this is why it should be interesting for you as well. And it's interesting because these people, they have access to the crown jewels, everything. If you're a developer at a modern organization, you have credentials, you have SSH keys, you have passwords to the most important production software that powers your business. You have direct access to the local copies of customer data. I can't tell you the amount of times that we found customer data where the developer just had it on there temporarily because they had to reproduce an issue, and then they just forget about it. They have read-write access to the technical organization's most important intellectual property, and in many cases that's their source code or their trade secrets or whatever. They're the ones that are just dealing with it every day. It's on their machine. They have copies everywhere because they're constantly iterating, and they're the ones that are building it for you. So these folks, if you think about like the risks across your organization, these should be at the top. Like these are your VIPs in terms of if these devices get compromised, this is where you're going to have a reportable incident where you're going to actually have to reach out to someone. So the common thread, though, is you have a lot of developers there, and you'd think, okay, well, these people just have to institute like a pretty standard security policy and guideline. And all the companies that we've worked with, and I would just say in general, they already have a rigorous security policy. It's there. They have it there during orientation. They often supplement that training throughout the organization or the employee's career at the company. Like they have this pretty locked down because a lot of it is like a requirement. If you're going to do business with another organization, you need to have a pretty competently prepared security policy and then proof that you're actually training your employees on it. So what I'm going to try to show you today is that software engineers, due to the nature of their jobs, are actually forced to temporarily undermine the security of their Macs while simultaneously handling the company's most sensitive data. They have to. It is just impossible for them to do their jobs effectively without temporarily mucking with how the device works or creating these sort of weird situations where data can suddenly become, exfiltrated out by an unknown third party. And the big problem is, like, if we were actually looking at the issue, it's because we're all humans. These people are forgetful, and the second that they turn off their firewall because, oh, my Docker doesn't work, and like I can't get the containers to communicate with each other, never goes back on. Just never goes back on. And so as administrators and security technicians, it's our job to not only effectively monitor these policies or potentially optionally enforce some of them, but to also let the users know when they are in violation of the security policy that you have. Zach said this yesterday during his talk, and I totally agree with it, is that most people that work in your organization, they don't want to be the source of the thing that actually takes the company down. They don't want to be insecure people. But it's hard for them to get an understanding when you have a flat document that says you need to have the firewall enabled, you need to have full disk encryption, you need to have this, that, and the other thing. They have no real actionable feedback there. Am I even compliant with that? Was I compliant one time? Am I not compliant with that today? They want that access. They want to know if they are compliant or not. And there just aren't a lot of great tools out there today that give them that instantaneous feedback on whether or not I'm actually, causing a problem for my organization. And you guys don't have a lot of great controls to potentially block folks that aren't properly set up from important access to things that they shouldn't have access to if they don't have these basic level of security controls there. So we're going to talk about a bunch of security controls that are undermined by engineers. And I'm going to show you a few examples of how it happens. And then we're going to kind of like dive into our products and some open source stuff to kind of talk about that and how you can actually detect these things and then do something about it. So we're going to talk about VPNs and firewalls and other sort of network security controls designed to prevent outside scrutiny of internal systems and how developers frequently with a single command just get around all that and potentially expose really private data to anyone who wants to just guess it at a URL. Hardware and kernel level security control, system integrity protection, disk encryption, even something simple as disk encryption. We'll talk a little bit about that, but all it takes is a few things that they do from a backup perspective that totally undermine File Vault 2. And secure authentication schemes. This is now transcending the desktop or the device itself and talking about the services that they log into. A lot of folks use like, key-based auth, like logging into servers. Two-factor authentication is like a must now. And a lot of people are just still even getting to that point. Like, let's get two-factor on, GitHub, or let's get two-factor on G Suite or whatever we have. There's a lot of gotchas with two-factor as well that you can actually detect on the device that can undermine the efficacy of that control. So the challenges here is like, okay, I've enumerated a lot of things. How can we detect these controls are actually being undermined? What is the evidence that it's actually occurring? How do we detect it across multiple devices and platforms so I don't have to like deal with this on a one-to-one basis? If I have 300 devices, I'm just not going to have an opportunity to do that on a one-to-one basis. How do I even inform the users they've disabled something important? If I don't have the capability of enforcing it today, how do I even let them know? What's a way that's actually going to scale where I'm not going to be on the phone, kind of playing whack-a-mole with this stuff for like the next, 4 years of my life? How do we get enough context to ensure these situations are even bad? Sometimes, like I said, temporary disabled. Like that's sometimes okay. Like if I'm a developer, I need to disable the firewall for like 5 seconds to actually test something and I put it back on. Was that really a security risk? How do I get the context to actually what the user was actually doing to understand in situ what's actually happening where I can make a determination whether or not we actually have a problem here. So we're going to transition now into a tool called osquery. So how many folks have heard about osquery before? Just raise your hands. Okay, vast majority of you. So we're going to still talk about it, but we're not going to go as deep as we did or as Zach did before. There's going to be also subsequent talks later in the conference that talk about osquery as well. But I'll give you some of the key facts here, and this will just be a few minutes if a lot of this is repeat. So osquery was actually incubated at Facebook by my co-founders, Mike Arpaia and Zach Wasserman. So when Mike joined Facebook several years ago, he was sort of in a position where Facebook at the time really needed to get more visibility across its endpoints. And they were looking at a lot of the commercial vendors that were out there, and all of them suffered from the same problems that I sort of enumerated earlier. They treated Windows as a first-class citizen. Mac and Linux were sort of either an afterthought or just straight up not supported. And that just didn't match Facebook's topology at all. They had all their workstations except for like the finance people and maybe a few sales folks or something. Like they were running Macs. The vast majority of their production infrastructure, if not all of it, is on some variant of Linux. And so having, some sort of endpoint monitoring that didn't treat those two platforms as first-class citizens was just a non-starter. So Mike was sort of tasked with creating an agent that would be performant enough where it would pass the scrutiny of the Facebook compute teams and their security teams, and would also be varied enough where you would actually deploy it also on workstations and from the same interface get all the data that they need to monitor in a single pane of glass everything that's going on every device in the organization. And so Mike set forth to kind of build this thing, and he luckily kind of stumbled upon this really awesome analogy using SQL. So what osquery does, which is really cool, is it takes your entire device and it creates this sort of analogy to a database, like a relational database. So it takes your processes, your apps, the network connections, the ports, all that stuff, what's going on in the kernel, like what's happening in the BIOS. All those things are like tables in a virtual database that you can actually query with standard query language, SQL, which is really, really powerful and simple, and it kind of matches that Unix philosophy of let's do one thing and let's do it really, really well, and they just sort of ran with it. So they deployed it everywhere, hundreds of thousands of systems at Facebook. It grew up and iterated on top of there where you have a Facebook compute team where if you use 30 extra MIPS on the server, it's costing times a billion servers. It's like $40 million or something of extra cost or something. That's what it grew up in. So from a performance standpoint, it had to meet that bar of having the least performance impact humanly possible. And at the same time, workstations are just as important. As soon as the developer hears that fan kick on, let's open up the activity monitor, let's see what's going on. This is going to be a non-starter, so it had to also be performant on the workstation as well. So luckily for us, it was very successful within the organization, and Facebook open sourced it in 2014, and it's still supported by the core team there. Zach updated these slides, I think, yesterday or maybe the day before, but the communities really ran with this thing, and since Mike and Zach left Facebook to join and kind of found Kolide with me, we've obviously been contributing a lot, but the rest of the community is really kind of kicked up in terms of supporting this thing. So this is really rare to have an actual viable endpoint security monitoring agent that's open source and isn't just dead on arrival in terms of community support. This is something that's really special, and as a result of that, for example, I would say of all the new tables that have been added in the last year, I would say 80% of them have been added by community members. And that's because someone had a need, the documentation is really good on the platform, and they're able to just add the stuff really, really easily. So there's a lot of benefit to being open source. So the goals of osquery are that it has first-class support for Mac OS and Linux. It didn't even support Windows from its inception. Windows support was actually added later, 2 years after the creation of the project, or after it was open sourced. And the goal here is just to enable developers and non-developers to access and aggregate data across disparate sources. So like everybody's got processes, everybody's got, these sort of Unixy type of concepts across, Mac OS and Linux, and some things even transcend into the Windows. Like how can we actually create these tables that will present the same types of information, even if it takes totally different code to access it in a singular table? And that's really like the power of osquery. And one of the first class goals there is how can we get all that disparate data in a schema that makes sense to everybody while maintaining the performance and reliability across the actual infrastructure that it's deployed on. So mentioned this already. It's a little bit of an eye chart, but basically you can access nearly anything that really fits into the sort of category of security monitoring or just like kind of regular IT administration from osquery. So flat files, SQLite files, system APIs, application APIs, eventing type things. So like process execution, file events, file system stuff. So like shared folders, file hashes, permissions, any plist on the system, you just can access and get like a perfect representation in table form of what's in that plist. And just so many more things. This is another eye chart if you were at Zach's talk the other day. This is just a selection of some of the tables that exist on just Mac OS. And if you go to osquery.io/schema, you can actually browse through the entire list of tables. So on the Mac alone, there's around 150 tables. More are being added every single week. And some of them are really impactful. Like these aren't just like minor additions. So this is using the power of SQL to actually get access to this stuff. So for example, you can just do stuff like select star from hosts, and then that's going to actually enumerate everything that's in your Etsy host folder. Just what's in the keychain. Let's select star from keychain items and get a sense of the metadata that's in there. Let's look at all the file events that have happened in these folders that we want to monitor. Has something changed on this file system that really shouldn't be, like through normal user activity, or if it's a server, nothing should be changing there. So let's monitor the files. File hashes, there's just a lot of power here. The problem though is the power comes with this sort of realization that you really need to have a plan. You need to know what you want to, you need to know what you want to know, and you need to know how to effectively sort of go from these very trivial to execute SQL queries into really, really complicated sort of queries that can join across multiple tables. And then, oh, by the way, we need to kind of like play with some of the data here because it's not quite how we want it. Like it can get definitely pretty gnarly. Like just a simple example here. This shows just showing like users joined on groups essentially. And like, I have to now write the select statement, have like a join command. And I'm not trying to like dissuade you from using like learning SQL and using this stuff. But eventually at some point you feel like, oh, I'm back in Python land and I'm scripting again, except now I don't have a real programming language. Like I have SQL at as my only tool here. And so there's a lot of power here, but there's also a lot of gotchas. And so my hope is to kind of show you that for folks who really get this, but aren't necessarily interested in investing hours or days or weeks of time to actually pull really interesting information from the device itself and present it in a way that's going to be actionable to not only you, but your team, your boss, all that stuff. That's kind of like what we're trying to accomplish at Kolide. So just really quickly, who's using osquery? A lot of great companies. These are just the companies that have publicly just shared the fact that they're using osquery either through like a blog post or they're hanging out with us in the osquery Slack. It's really fantastic that these types of organizations are utilizing it instead of like doubling down on some proprietary vendor sort of agent, and then all that additional effort and stuff that they're kind of investing into it gets lost. It's becomes sort of centralized just to them. So this is just like a smattering of them. There's, I think, hundreds of organizations that are really utilizing it effectively that just are satisfied and they're not, shouting it from the rooftops because they don't have a blog or they just don't have a reason to do that. So I was going to demo osquery I a little bit, but based on kind of where we're at in terms of time and stuff, and based on the fact that a lot of you guys were already at Zach's talk and possibly like the security workshop where that was happening, I'm not going to spend a lot of time with osquery I, but we can get back to that if you guys want to really take a look. I'll just show really quickly that if you guys haven't had an opportunity to really play with it, that it's actually it's pretty cool. So I'll just pull it up really quickly so that you can see. But so to get osquery on your computer, you have to just install the package from osquery.io. A lot of folks may have installed it via Homebrew because I think that's what the guy at the workstation said to do. But the Homebrew package can be sometimes really out of date, or it has like all these extra dependencies that can come with it. So I recommend if you already did that, just uninstall it from Homebrew and then just install the standard installation package there. So I'll tell you about a table that I wrote just really quickly that that's going to be released in the next version of osquery. And this is a little bit more like getting into the practical side of stuff. This is nothing to do with security, but I think it's like a really awesome way to just save your company money. So in osquery, you just type osquery I and you're presented here with like basically a live shell where you can type any SQL command that would work in osquery. And if you write .tables, you can get a sense of all the tables that are there. But the schema documentation on the website is phenomenal. So I would take a look at that in just like a separate window if you need to. One of the tables that I worked on recently was a battery table. So what I'm going to do is I'm actually going to put osquery in something called line mode, which will make the output look a little bit nicer so that it doesn't look like this crazy ASCII table that's going to not work at the resolution that I'm at. So this is really cool. I put this together because I realized that there was a ton of organizations out there that have a lot of Macs that have a battery that's not in good condition, but the Mac is actually in reasonably good shape. Like it's within the warranty period or has some sort of allowance from Apple because there was some sort of return policy for the recall for the battery itself. So the power here, what I'm trying to show you is like, yes, there's command line commands that you can actually run to get the battery information from all the devices in your organization. But are they actually interpreting that information in a way that is actionable for you? How many of those are providing like a key for the condition of the battery in a way that requires you to, that allows you to actually go, oh, let's do like a select star from battery where condition is needs service. Or state is or health is bad or poor, and being able to do that across an entire fleet and then juxtapose that information with the actual model number of the device itself, that gives you basically a list of devices that you can return to Apple for like a complete refund, and like that's straight up just money in your organization's pocket with like one or two queries right there. So that's an example of like a really trivial sort of thing that you can do. That gives you a lot of visibility into the system, and so that's just there to show you that this information is available to you, and you have this access to the shell at any time when you need to just get a quick answer on an individual device. Anyway, I would definitely check out Zach's talk when it's posted online, and there'll be a talk later on that I'll pump up next to kind of talk a little bit about if you want to get more into this side of it. Okay, so that was osquery I. Now, this is where things get really powerful, and this is really where we're going to start dovetailing into some practical examples. But I just want to talk a little bit about the tech in case you weren't exposed to it. So osquery actually ships with two components. One is osquery I, which is the interactive shell that we just worked with, and osquery D, which is the daemon, which actually runs as sort of this agent in the background. And essentially what it allows you to do is you supply it with a query schedule. And you basically tell it, okay, these are the queries that I want you to run. This is how frequently I want you to run them continuously. And then every time that you notice a change in the results from when you actually ran it, let's log something to a log file. And that way, we can actually see how data is changing on the device throughout its life cycle. This is really neat because a lot of these queries can produce a lot of information, but you really only care about the differences. If I'm running select star from apps every 60 seconds, that's going to produce, potentially hundreds or if not thousands of rows every time that it executes. But if I'm getting a differential query on that, I can actually see the apps that are added and removed over time on the device. And then as those log events come in, if I have some way to put rules on top of that and say, oh, show me if the user installs an app that has this name or has this version or it's in this path, that's actually pretty powerful. Now I have some visibility into maybe what the user is doing, and I can actually maybe action some of that information. So this is like the core concept that Kolide software is built on. It's very simplistic, but when you have this capability to kind of continuously schedule these queries, get these sort of differential logs, these are the building blocks of a really powerful engine that we can actually use to ingest this information and produce a lot of cool data. Here's what the schedule looks like, by the way. It's basically like a giant JSON blob, essentially. And you just supply it with a name for your query and an interval, and there's a bunch of optional keys that you can add there. And the reality is that managing these schedules can be really cumbersome. It's a real pain. You're editing files now. How do I get these files on the system? And osquery comes with a lot of cool sort of remote capabilities. And if you have built an osquery fleet manager, you can actually tap into this stuff and start scheduling queries remotely and running queries remotely and getting the results instead of returning them to a file. You can have them be returned to a server that you own. Now, writing some of these things is really kind of tough. I would say it's not incredibly difficult, but actually doing it in a way that's intuitive where other users can actually take advantage of it can be a little bit tricky. So we built our own, and it's 100% free. So if you guys want the ability to run these queries en masse, and you just want a server that communicates with this osquery capability, check out Kolide Fleet, which is kolide.com/fleet. It's free. It's 100% open source, and there's a few other open source fleet managers out there, but we're trying to make ours, I think, one of the best, and it provides a really awesome user interface for kind of looking at some of this stuff. In fact, you know what? Let's just take a quick peek at it. We're not gonna spend too much time there because I want to show you Cloud, but I will just show you this really quickly, and then we'll start getting back into some of the more actionable stuff. Yes, that's correct. This is a little bit older version of Fleet, but this is what it looks like on our corporate environment. And it's really cool. So you log in and you just have all the devices that are there. You can see their current status of whether or not they're online or not. And I'm not going to go into this too much because it'll be spoiling Lucas's talk. But it's just really neat. You have the ability to kind of filter on the sidebar here, whether for online devices, offline, newly enrolled, if they've just gone MIA and the agent isn't working, by platform. And osquery itself, Fleet also supports all the major platforms. So Mac OS, the various flavors of Linux, and Microsoft Windows as well. So you can have them all on a single pane of glass, able to be queried from a single interface. Another really cool feature of this is this kind of neat thing called smart labels. And this is a feature we also have in Cloud as well, where you can, using a SQL query, actually dynamically group the devices in your organization by some characteristic. So when we first invented this feature, we were like, oh, people will kind of group things by organizational unit. And then what we noticed is people were grouping things by bad things. Oh, show me all the label, make a smart label where SIP is disabled or automatic updates are not enabled properly anymore. And you can just kind of dive right into that. Or they have an unencrypted primary disk, or automatic updates is disabled or something. And you can create as many of these labels as you want with just the simple SQL query, and it runs, and if it returns results, it will be in the label, which is pretty neat. We also, I mentioned those sort of that query schedule. Basically, what you can supply to a query schedule is something called a query pack, where essentially you can define a set of queries and the frequency that they run at. So you can find a little bit of a better one here. So here's a query pack called host info, and it has all these various queries here on the side. And then these will just run out to all the devices that are now connecting into Fleet. And so from this single interface, you can schedule the queries, set the intervals, and then all the log results will come back to Kolide Fleet, and you'll get just this concatenated log file of all these results that you can actually put anywhere that you want. So if you have Splunk or Elk or some sort of like log aggregation platform, this is a great tool to just get some really good info into those existing tools that you have today. There's also a live query feature where basically you can write any query that you want against the infrastructure and see the results instantaneously. I'm not going to demo that because I want to show you the live query in cloud, but it's really cool. I mean, you just write a query, all the documentation for all the tables is right here, has autocomplete, and you have like this great target selector where you can find all the devices. You can even select by the labels that you made earlier, which is really, really neat. So regardless of what you guys choose to go with, if you're really interested in osquery, this is a viable option if you have like a really difficult procurement process or like you just want to kind of get started. This is a great way to kind of really check some stuff out. And so a lot of great instructions for getting this set up locally in your environment on our website. And then we also have a Slack channel that I'll kind of promote at the end where we can give you some community support for that as well. But anyway, very powerful stuff, and this is a great way to just show off like kind of like the raw power that you have when you have osquery properly reporting into an engine that that like actually works.
Can I ask you a question?
Yeah, sure. Here, I'm gonna throw this at you just so that I think just for the recording, just so they can hear it. Oh, it's not on. Is there a switch for it or something? I guess I'm not supposed to throw it either.
That's better. Hello? Oh, look at that. All right. So this looks really cool for seeing what's going wrong or right. Does it have the way to correct anything that it finds? Like, can you integrate it with something that automatically turns something back on or you know, puts up a nasty message or something like that?
So great question, by the way. I would say the key thing there is osquery by design is read-only. I don't think I mentioned that, but it's really critical. osquery cannot actually change the state of your device like through the intent of you, the administrator. So, and that's like a huge like security tenet for the actual core team. Like they were not going to introduce anything to core osquery that would allow you to directly like remediate or delete files or kill processes. That being said, there are a ton of folks out there that are writing what are called osquery extensions. And they, using the same SQL interface, allow you to do some of those things. For example, Trail of Bits, which is a consulting company, they actually help build a lot of the Windows support in osquery. They just recently released a sort of experimental extension that allows you to control the application firewall rules using like an insert command, which is really, really cool. There's other folks, I think there's like a Santa plugin that I think someone was talking about earlier that actually allows you to kind of interface with that. So that future for osquery is coming, and it's coming now. When we get into cloud, we have our own sort of, I would call it almost like a wrapper around osquery that we call Launcher. And Launcher, I'll just throw it up on the website really quickly. Launcher solves a lot of problems for people who are really trying to do this for real. So what I mean by that is the number one problem that you have to solve, in my opinion, when you're rolling out osquery to your environment is auto update. Because as I mentioned earlier, there's new tables being added every week, and I guarantee you're going to want to use them as soon as they're available, because they're often like, oh my god, like the battery thing I just mentioned, like I just want to run that once, like even if I'm only going to run it once, like I want to have it working on every single device. So we created this thing called Launcher, which basically is almost like an osquery extension, and it adds all these additional capabilities. So it has a really secure auto updating capability. We have some like packaging tooling so that you can really easily create .pkgs that instantaneously connect to something like Kolide Fleet if you want. And then we use this mechanism for Kolide Cloud, which I'll talk about later. And then we've also added a different communication protocol that's a little bit more performant. Instead of relying on HTTP calls, it uses gRPC, which is like an actual proper RPC service, so that we can actually do some really cool stuff with the agent that's a little bit more interactive. And that's going to tie into some of the remediation stuff that I'm going to talk about with Kolide Cloud a little bit. So to answer your question more succinctly, core osquery remediation isn't possible. Using the APIs in Kolide Fleet to tie into like some other tool that maybe can do it, like to like throw out a script that's going to clean something up, definitely possible. And then people are now adding extensions to osquery to actually also allow the ability for sort of external remediation, and then we take advantage of some of that stuff in Kolide Cloud to actually give you like a really awesome experience around it. And I'll demo that a little bit later. Good question. Okay, so where are we? So just really quickly, I'll just throw this up here just because we're almost done with the slides, I promise. This is the talk that Zach was promoting. Using osquery via Fleet for client-server visibility, Lucas Hall. Lucas doesn't work for Kolide. He's just a fan. And we found out that he was doing this talk, and so we got him all hooked up with the latest version of Fleet. It should be a really awesome talk if you guys really want to take some time and learn from someone who really went down this path of the DIY. And this is a great opportunity to like get some experience writing some of these things. All right. Let's talk about like some real practical stuff now. Sorry that took so long, but I think the wait will be worth it. So going back to our original premise, like what are developers doing that are going to be like really concerning? So I want to talk about this thing that a lot of developers do that I'd say like 50% of the folks in this room probably know about, but it's like something that you don't really know how to detect very easily, and they're called reverse sort of public tunnels. So there's a tool, the most popular one of them out there, I believe, is called ngrok. Has anyone heard of ngrok or used it? A few folks, okay. So ngrok, this is really crazy, but this is legit. Like I'm not pulling your leg on what this tool is and how many developers actually use it, but it's a tool that they run, and it allows them to create an instantly publicly accessible URL that directly routes to the local host. So it just straight up blasts through any firewall, VPN that you have, and then just directly allows any traffic from the public internet to whatever service they decided to bind it to on their local host. Like there's no like password or anything like that. Like they could just ask whatever they want. So this is often used by developers to frequently share the progress of development, or if they're working on mobile, like, oh man, like how do I get the mobile site that I'm working on my local host on my iPhone so I can like make sure that it like works properly? So they just throw up an ngrok tunnel, which is fine. Like, okay, that's not bad. Like I'm working on like a marketing website or something, like that's not gonna kill the business. But what happens is they never remember to turn it off. It's just sitting out there like waiting to bind to any port that like starts to spawn up. So maybe they were working on the marketing website, but then maybe the next day and the laptop hasn't like turned off like legit, like hasn't restarted. The ngrok tunnel's still running, and then they bring up like the production code for they're trying to troubleshoot a real issue. And because they don't like want to log into their own prod, they've like short-circuited the login there, and like there's a real production database in there because they're like trying to solve a problem. And then you suddenly have like a unprotected public URL where all your customer data is just instantly accessible by anybody who can guess this URL. And like you're thinking, okay, Jason, like that's a lot of what ifs like in a row. Like, is this a real legit problem? This has happened to our customers, and because we had this detection, they bought our product. So this is not something that doesn't happen. This happens on a regular basis, and there's folks out there, because these URLs are really easy to guess, they just troll through them, and they're looking for interesting stuff that looks like something they could potentially compromise. So how do you detect this? How do you detect this with osquery even? Like, this is crazy. Like, how do you actually find this? Like, we didn't even think it was maybe even possible to detect this with osquery, but we came up with a query that does it. This is what it looks like. So what this is actually doing, it's using a table called curl. So the curl table actually allows you to, using the device that you're running the query against, reach out to an external URL. When you run ngrok, ngrok not only spins up this like tunnel, but it also spins up like a local API that allows you to like understand what the tunnel is doing. So what this actually does is allows you to query this sort of internal API, and then using this function called JSON extract, we can actually look at the tunnels key and see all the tunnels that are in there. This is crazy. Like there's a lot of stuff going on here, really, really difficult to write. And all it produces is this single piece of output. ngrok URL equals, and then the URL of the tunnel. So that's great. Like, okay, we have a query here. Everybody can run this on Kolide Fleet today, but how do I actually get this information in a way that's more contextual? Okay, like when was this tunnel started? How do I, if I run this on Kolide Fleet, how do I know like when the tunnel was stopped and then started and stopped and started? And how do I actually know, like, how am I going to be alerted if it like was only running for like a couple hours and then now I'm running the query now and it's no longer up? Like, have I missed that data potentially? What was on the tunnel? Like after it's closed down, like maybe it's not accessible anymore, but it was open for like 4 days. Like what was actually going on there? This is all like important information. And these are the types of analytical type of questions that we want to be able to kind of help you answer in Kolide Cloud. So what we're going to do is we're going to pivot over to that, and I'm going to show you this distinct example first, and then we're going to kind of dive back out to the entire Kolide Cloud interface so you can kind of see how it works from like an overview perspective. Cool. So this is the interface for Kolide Cloud, and this is the dashboard. So basically here, I have a number of alerts that Kolide Cloud is actually already telling me about. I have these ngrok tunnels. I have some plain text one-password recovery kits, some unencrypted SSH keys, unencrypted time machine backups. Those are really important. I'll talk about those a little bit later, but essentially, if you have full disk encryption enabled, then your employees are making unencrypted time machine backups, like it totally defeats the entire purpose of having it, because they're typically storing the backup device with the actual laptop, potentially in the same bag. If it gets lost, you still have like a reportable incident. So if you come from like a healthcare organization or a school where there's like, you know, PII or like really important like student information, or you come from an organization where that has code or like a local production database on it, that's a major problem, even if you had full disk encryption to kind of back you up. GitHub two-factor codes, we're going to talk about these as well. A lot of folks enroll in two-factor authentication, and then they just throw the backup codes in a downloads folder, and then like that downloads folder gets like synced by Dropbox, and then just like out there in like this really crappy personal Dropbox account that just is ready to be pwned by anyone because they're reusing passwords everywhere. So these are like the types of events that happen over like a period of time. Like there's 3 or 4 instances of things that all have to go wrong for this to happen, but given enough users, given enough machines that are all doing the same type of activity, you're going to have 3 or 4 that make it all the way to the end. And then all it takes is one final thing to happen, and then you have a major reportable incident that was really difficult to find. So what we're going to do is we are going to go to the devices view here, and then we are going to click into my device. One thing I want to point out is that we actually do user-to-device association for you in this product. So like on Fleet, you just saw the host names there, and if you don't use like a host name scheme that allows you to easily identify your users, we'll do it for you. So if you have something like G Suite, we'll pull in all those employee names for you, and then using osquery itself, we know where all the locations are, where we can kind of, using a confidence algorithm, figure out which device actually belongs to who in real time. So that way, every time that you're dealing with a workstation at least, you know who's driving it, and you can actually click on the person, see how many devices they have and what state that they're in. So I'm just going to open this in a new tab. So here I am on my device. So as I mentioned before, I have a number of alerts already set up for me. So a couple things that I'll point out is that we have this section over here called practices. So practices allow you to define the security policy that you have in your organization, whether or not this individual user is compliant or not. So there's a number of them to choose from. and basically they're just SQL queries. They're just like the smart labels in Fleet, actually. And if the data doesn't return or does return for a particular practice, we'll actually show it to you, and we'll measure that over time. And in this case, on my machine, I don't have SIP configured, so I'm a bad boy, and I'm like not compliant right now, just for the purposes of that. So, but let's get into the alerts, because that's what we were talking about here. So you can see we have a number of alerts for my machine, so that we'd have a pretty good demo today. Hopefully you guys aren't walking with the impression that I'm like my own worst enemy.
It's not a butterfly or anything.
That's right.
Jason, can you zoom a little bit?
Oh yeah, sure. Oh, I'm sorry. I got lost here. Where am I? Okay, sorry about that. Is that a little bit better?
Maybe like one more. Yeah, perfect.
Sorry, guys. Wish we were in like portrait mode or something for the projector there. All right, cool.
Nice console. We want to see it.
I know, right? We spent a lot of time getting just that product image in there, making sure that automatically detected. All right, so where were we? ngrok tunnels.
Sorry, was this Fleet or Cloud?
This is cloud, so we are in cloud now. So here I am with ngrok tunnels. So there's 2 tunnels open for my environment. Every time that you run an ngrok tunnel for an HTTP service, you actually end up creating 2 different tunnels, one for HTTP and one for HTTPS. So that produces 2 different alerts. It shows me how long I've been running them and whether or not this is still happening or not. So if it's actually not happening anymore, we will still show you the alert there, and then you have the opportunity to dismiss it. We don't do that for every alert. We only do that for the alerts that we think are really important for you to look at, even if they're no longer happening. But for certain ones where, like as soon as it's like dealt with, it can go away, we have like an auto archiving process as well. So if I click into this, there's a lot of great detail in here. So we spent a lot of time for a lot of our alerts, like giving you guys a really awesome breakdown of what's going on, what was accessible, what is even an ngrok tunnel, what are the risks, and this is stuff that's not just for you, but to like explain to someone else in your organization why this is bad, potentially even the user themselves. One thing that we do with our ngrok query now is we also detect if the user has actually added basic authentication to the ngrok tunnel. So if they've actually taken the time to password protect it, we won't produce an alert. And we actually point the user to documentation that you can point them to on actually how to do that. So if they insist on using this, like be like, okay, well, at least put a password on it so that no one from the internet can just like hop on and see what you're working on, especially if it potentially has customer data. So what was I doing? Well, when we collect this information, we capture a bunch of information that you just can't do from the osquery SQL syntax. So this is doing a little bit more stuff under the hood. So for example, I have the entire HTML of the ngrok tunnel that was returned the last time that we actually introspected it. And for every event, every time that this ngrok tunnel runs, we're recording this information. So if it changed over time, we'll give you a sense like, oh, at this point it was fine, but at this point it was like the production problem. So here's that. But to me, like this is not really helpful. Like I don't want to sit down and like read HTML all day. So for me, it's like, okay, let's actually get like the real view of what we're dealing with here. So we actually produce a screenshot of the actual site that they were working on. So in this case, I was working on the microMDM website for Victor, and I could see like, okay, that's probably not a problem. But we take a full screenshot of the entire page, and it's rendered in line here so that you can actually see what was happening at the time that it was happening. And you have all the information you need here to like make an actionable decision about whether or not this tunnel was an issue. And of course, we still have that like basic event data that we have from the original query response if you want to be able to access that. All right, so like let's just pretend though like that this is a really big deal and we can't get in touch with the user. Like we're calling them like, hey man, like you need to get this thing down. Like how are we going to actually resolve this thing? So this is a new feature that we're adding to Kolide Cloud. 100% optional, but it's up to you if you're you want to enable it. So I can actually click on the device, go back to that view that I was at. Oh, I cannot. That's weird. Okay, weird. And I can actually remote shell into the computer. So this is an optional add-on to Launcher that allows us to, through a secure connection via WebSockets, to actually shell into the computer live, and then to run a command in like a fully compliant TTY emulated shell. Question.
Is that going to be an option in the hosted, self-hosted version?
It will not. It will not be. We'll have all the primitives in there so that you can do that, but it's not going to be an option in the like the actual like wired up like user interface and all that stuff will not be available in Fleet. Yes.
Do you have to be on the same network as the computer, or are you doing some magic so that's not the case?
You do not have to be on the same network as the computer. The computer could be anywhere. So it could be on corp, off corp. Yeah, so no, they don't have to be on the VPN. They could be in Thailand and you're in the US, like on vacation. You just need to shell in and you're ready to go. And it's awesome. So here I am. It opens up like a full screen view. Oh, go ahead. Another question.
Yeah, just a little more clarification. So you said in Fleet, you said like you would be like if we'd be able to use like Fleet CTL to get into that.
At this point, no. It's an experimental feature. So when I say like the hooks are available, Launcher, the agent that we use in cloud, is actually open source, just like osquery is. So when we ever build a capability that we need to take advantage of in Kolide Cloud, we open source it into Launcher. And so all the kind of base level components are there. If the industry wanted to come together and build this sort of capability into Fleet. But the reality is that we think this is a killer feature, and we want to make sure that it's we want to actually try it out in the cloud version first, and like really understand where the use cases are before we start like potentially transferring that stuff over to another platform. But for right now, it's only in cloud, and I think that that's probably going to be at least our position on it. But if someone were to come in and make a change, Mike, you want to say something?
I'll just add that the idea of Fleet is to like be a really awesome OS query management tool, not necessarily to fulfill all of the like things that you would want to do with host instrumentation. It's very like streamlined to allowing you to manage the interfaces that OS query provides. And with Launcher and Cloud, we kind of, OS query is not the full story there, so we try to expand it. So this is a good example of how you might see like some differentiation between those two platforms, in my opinion.
So here I am in a shell, and it's a regular shell. Like it's not like a fake shell. Like, but this is all running in JavaScript in my web browser right now. So I'm actually in Chrome, and this is running, and everything basically works. Like if I run top, for instance, like all these types of things that I would normally expect to run properly in like a proper like Xterm type of interface work great. So in my case, I actually want to kill the ngrok tunnel, right? So let's.
Jason.
Yes.
Sorry, just one question. So this is a standard user account?
Oh, in terms of who I'm logged in as
Yeah.
right now? Yeah, so I'm running Launcher with drop privileges right now on my local machine. But in practice, this actually runs as root. So you will have root access in a normal sort of shell situation. Just to answer your question.
Yeah,
like
just because
legit,
there are other remotes, I want to go out and help someone / find some information. Bomgar is one of them. You get a nice Java console up, and it's always root. And there's not much way to drop those privileges once you start a session. And it's also kind of like, hey, you're immediately in danger zone the moment that you remotely connect to that machine, because with great power comes great responsibility, but there's no like option of, okay, I'm going to actually escalate.
Yeah, so in our
Just curious
case,
about
just to explain the actual behavior, because I'm cheating a little bit here because I'm running Launcher locally, is you would normally get root access straight out of the bat. You have the ability to drop privileges just as you normally would in a shell. The issue with running it as, we could probably build in a default to like actually drop you into what we believe is the default user of that thing by default. So that may be something that we look into if we hear a lot of feedback that we don't want to be in the danger zone, as you put it, immediately. So that's great feedback, and we'll definitely take that to heart. This is a brand new feature, so we're really interested to see how people potentially take advantage of it. But we do want to allow people to access root, because a lot of the stuff that you need to do, you kind of need to be root for. Like in our case, we're about to kill a PID perhaps or something like that, and we want to be able to actually kill it properly. Yes?
Is there any logging around what you're doing here?
Yeah, so we are adding audit logging around the launching of the shell itself, and then ironically, OS query allows us to pull bash history using actual osquery itself. So all the commands that were run under that account, we can pull from that time. So using those two kind of events, we can correlate an audit log. We don't expose that audit log today to the user, but it's something that we plan on doing in the future so that you have full audit capabilities across this, because we recognize that this is like, with great power comes great responsibility type of stuff here. So I'm just going to sue in to cheat just so that we can see that we can be root. But here we are in root. So let's look at that ngrok tunnel. Okay. So there's our that's not it. It's this guy, right? So it's just, what is it? I'm getting nervous around like my Unix capabilities here. Was it kill 9? Is that what it is? Help me out, guys. All right. So our ngrok tunnel should be stopped now. I'll just double check that it is. And we can see that it's no longer running. Now in a few minutes, when osquery eventually reports this out, we'll be able to actually see that the alert still is there, but it actually is not ongoing anymore. We can actually see how long ago it ran. So we'll check in on that in a second. And while we're doing that, I'm going to just kind of show you a few other things in the web interface, basically. So what we'll do here is, so you saw the overview page already. This is really cool. A couple things I'll just show you at the bottom here is that we're creating this dashboard so that you can actually measure how your fleet changes over time. So if you actually want to check, okay, how many macOS builds do I have, and like how are they changing over time as I'm rolling out patches and things like that, this is a great tool to kind of get an assessment of where you're at across all these various versions that we're seeing in your environment over time. We're continuously collecting that. We're doing the same if you run Monkey and you want to see like how Monkey versions are changing over time. We add that capability as well. We're also doing this really cool visualization around just the macOS versions in general. What we wanted to show is like make it really evident that you have potential Macs in your fleet that are running really old versions of macOS that are like just not supported anymore. So this visualization is kind of designed to show you, okay, I'm mostly in the High Sierra area right now. I have one laggard here at like 10.13.4. But if you had someone like just kind of chilling in 10.11.2, or God help you 10.8 or something horrific, the idea here is that you would be able to see that instantaneously and then be able to kind of click into that and see which devices are actually the ones that are that lag behind. You can see every enrolled device in the recently enrolled devices here, and then you get that breakdown of all of the awesome practices that you've set over time. And then we also measure your efficacy at meeting those practices over time as well. So if I click on, let's see, like the system firewall disabled stuff, I can actually see all the devices that are not compliant, the ones that are compliant, any ones that we weren't able to assess, and I can actually see how that's changing over time using this graph here on the side, which is really cool because, and you can export all this information to CSV, sort of sort through it, which is really nice. Now, a little extra thing that you can do here is that you can actually, we actually give you an optional sort of system tray icon or login kind of, or clock icon up here that you can actually deploy out to your users if you wish. And what this will do is it'll actually check into our Kolide instance, see which best practices you've configured, and then it will show them if they're not adherent to them or not. So I can see here, as you can remember, my SIP wasn't configured. So you can see here, it's kind of hard to see. I'm trying to figure out how to. Whoop. You can see here that that's not enabled, and then I can click this as a user and then get all the information about why this is a problem, how do I actually enable it over time. And SIP is a really tricky one because SIP was actually not enabled on a lot of the original touch bar Macs that actually ship from the factory. So this is disabled in a lot of environments, even though most users typically don't touch this. And this is a great way for you to be able to kind of click into that and really learn more as well. Sorry, I'm just trying to, how do I undo this here? All right. So getting back to the product a little bit, there's a couple other alerts that I just want to quickly show you. But before I do that, I just want to show you really quickly this other feature that we have called collections. So collections are really cool. They allow you to define a SQL query, and we ship with so many of them. And then we will collect all the data associated with that query continuously and have it programmatically accessible to you in this interface. So for example, if I wanted to look up all the homebrew packages in my organization, this would give me all that information readily accessible, and I can actually search this information instead of using SQL. I can use like an incredible like sort of Boolean builder here, and I can actually construct a search that I want to have over this data over time or export it. Now the other thing that we do for you in this as well is that we actually pull down the event stream. So I remember I mentioned osquery is like pulling in all these events. So as stuff changes over time, all that is also accessible to you and searchable within this interface. And what you can actually do is you can create your own little custom rules here for the search. You can save them, and then you can save them for later. So if you have like little slices into this view that you want to remember and like check back in on over time, you can absolutely do that. So I made like a little contrived one here, like homebrew packages just on like Jason's machine that I can see here. But this is like a really powerful way. Like if I'm doing it for apps, I can look for unsigned applications. If I'm doing it for Chrome extensions, I can look for Chrome extensions by like a specific developer that I may not want to see. So it's really awesome and powerful, and this is a great way to be able to kind of slice and dice the data within your organization. And the product ships with a ton of these. Finally, you can set up notifications in the application as well. So all those different like event tags that I just mentioned, you can set up like a Slack notification, an email notification, or if you have like a custom solution on top of that that you want to just pipe some data to, we have this thing called webhooks where you can just send like a URL sort of HTTP probe that says like, okay, this external service, like here's something that happened on my fleet, here's all the information. Now you do what you do, like if you have something that remediates something, or you have some sort of security orchestration tool, this is a great way to kind of set that up. So I know we're running really low on time, but I want to just talk about one or two more of those really quick sort of practical security things that we sort of ship within the product that you can detect. So one of those is unencrypted SSH keys. This one's really a big deal. What I was going to do is I was going to actually demo actually signing up for GitHub. And the problem with GitHub is that a lot of folks know that they need two-factor authentication, but like most two-factor authentication processes, they prompt you to download what they call these backup codes. So backup codes are like basically the keys to the kingdom. Like they're a flat file of valid codes that they allow you to basically bypass the two-factor prompt. In case you lose your phone or you lose the method that you have these backup codes so that they don't have to deal with your support call when you've lost everything. The problem is most people, they just click download because they have a download link on all of them, and they just go into their download folder and they just stay there forever. And basically, it's like as bad as having a passwords.txt file in like your downloads folder. Like it's like no different than that. And a lot of these people that are signing up for GitHub, they're often reusing a password from a previous service or site that has already been compromised. So if you guys have ever like checked out the site, Am I pwned? If I even have internet at this point. Oh, have I been pwned? Here's my Gmail. You can see just the embarrassing litany of things. And like, it's no one's fault, right? But look at this. Dropbox, lost everything. LinkedIn, everything gone. Like Geeked In or whatever this stuff is, like it's just totally compromised. So anytime I've ever reused a password here, that password is going to be instantly compromised by an attacker. And so if they can combine that information, like if that password, your email address happens to exist on some of these lists that are publicly accessible, coupled with the fact that they may have access to sort of your two-factor codes through like an inadvertent share through Dropbox, shared files, something like that. This is like a very easy way for all your developers to potentially open up a backdoor. The other thing is that when you set up GitHub, they also ask you to produce an SSH key. So like a lot of developers in GitHub, they're actually setting up SSH keys, and they're using SSH to actually clone repositories and stuff, and that gives you read access to the keys to the kingdom. And when they set up the SSH keys, they don't add a password to them. They're unencrypted, and same thing, like they end up in Dropboxes, they end up in Google Drives, they end up in shared folders and all this stuff. And so Kolide Cloud actually detects all that stuff, and we, oh my God, am I getting played off? Oh my gosh, guys, this is a first. Anyway, I'm just gonna plow through because I know that you guys are here and I want to make sure you get the information. But we also give you some of that information as well. So unencrypted SSH keys, we look at that. We give you the context for all that information. Unencrypt GitHub two-factor codes, it's all there. And these are the types of things that end up compromising your organizations. These are the things that end up leading to a pretty potential major compromise. So with that, I'm gonna stop right now. Obviously we're over time, but I'm gonna hang out and ask questions at the end with Mike and Zach, or answer questions with Mike and Zach. And you guys are welcome to kind of hit us up right outside the door so we can, go through a good Q&A process. Yeah, so great point. This is we have an unlimited free trial for this for 10 devices. So there's no excuse why you shouldn't sign up for it today. Get it on 10 devices and see what you want to do. Just go to kolide.com/signup and you just put your information in and you're right into the product instantaneously. And thanks, I appreciate it.